Alright, in this little activity we're going to be looking at how to calculate temperature inversions and why we would want to look at temperature inversions within our atmosphere. If we look at the background information, especially during the summer times, we hear on the news report sometimes that there's a high air pollution level or high air pollution count, and they recommend that we not go outside during the hours of 2 to 5 during the afternoon when it's the hottest. Reason being is because there are certain times when there are going to be high levels of air pollution near the ground, and when this occurs, we see the temperature inversion is occurring in the atmosphere. Most days, the atmosphere air is cooler the higher you move up in altitude. This is because most of the sun's energy is converted into an infrared radiation as it strikes the surface of the earth and then radiates from the surface. Warm air usually rises, it expands as it rises, and then it cools the higher up it gets. However, there are times when the temperature of the air actually will increase with altitude. These situations, you'll have warm air on top of cooler air, and this is referred to as a temperature inversion. When this happens, the profile of the atmosphere gets inverted, and this inversion process actually traps air pollution in cooler air temperatures, so it would actually be trapping it closer to the ground. So what we're going to be looking at is how does density change with altitude in normal air versus how does density change with altitude in a temperature inversion. That's what we're going to be looking at. When you look at these procedures, the first procedure is just showing you how to convert from Celsius to Kelvin, because we use Kelvin as our temperature reading when we're looking at absolute temperature and we're dealing with temperature within the atmosphere. The second procedure is going to talk about how you can calculate density when you're looking at these temperature or these air inversions or these temperature inversions within the atmosphere. Okay, so you want to be focusing on the first two procedures, procedure 1 and procedure 2, for this activity. This third part gets into some other information. You really don't have to focus on that. Just focus on procedure 1, getting your temperature in Kelvin, and then procedure 2. Once you get those finished, then you will get a chance to plot your data from set A and your data about what your X and Y axis should be. And once you get through plotting that, you'll get to analyze the graph and look for patterns to see if you notice the density change between one and the other. So how to do this is very simple. Okay, for procedure 1 here, you're looking at to convert to Kelvin, you just add 273.15 to your Celsius temperature, and that gives you Kelvin. Okay, so for example, if the Celsius temperature was 10 degrees, you add that to 273.15 and you get 283.15 for your Kelvin temperature. When you're calculating for density, and I'll work one with you or a couple with you to make sure you understand, but when you calculate for density, you'll take the density times the absolute temperature at a particular height, and that will equal the density times the absolute temperature at ground level. And we know we're going to assume that the density at ground level is going to be 1 kilogram per meter cubed. Okay, so here we go. Let's look at the first one. We'll get this rolling for us. So we're going to say that at height 0, alright, we have a temperature of 20 degrees, and we want to convert that to Kelvin. So remember that our procedure is, for part 1, that we take our Celsius temperature and we add 273.15. That gets us our Kelvin. So if you look, what we're doing is we took 20 and we added 273.15, and that gave us 293.15. Now to get the density of this particular air at a given height, alright, we look at our formula up here for procedure 2. And it tells us, and I'll write this on another sheet of paper so you can see. Alright, it tells us that our density at ground level is 1. We're going to multiply that times our temperature at ground level, and for the first part, our temperature at ground level, we're at 0 height, so we're at ground level, so our temperature at ground level is 293.15. So 293.15. That should equal the density that we're trying to solve for, which is going to be x. So the density we're trying to solve for, alright, times the temperature at that particular height. Well, since we're at 0, which is ground level, so our temperature is going to be the same as our absolute in this case. So that's going to be times 293.15. You should be able to solve for x. We know that x is going to equal 293.15 divided by 293.15. So x is going to equal 1. So for this first part, since we're at ground level, then our density is going to be 1. Alright, so let's move on to the second one. Okay, we're looking at, for a height at 100 meters, we want to figure out our absolute temperature. Remember, absolute temperature is 273.15 times our temperature in Celsius. So I'll just write it down here for us. So we're looking at 273.15. We're going to add that to our Celsius, which in this case is 19.5. Okay. So when you add these two together, you should get 292.65. Okay, so that should go in our temperature here of 292.65. And then we want to solve for density. So once again, we know that our density at ground level is 1. We're going to multiply that times our temperature at ground level, which we know we've already figured out is 293.15. That'll equal the density we're trying to solve for, and in this case it's going to be at 100 meters, and then we know the temperature at 100 meters is 292.65 because we just solved for that. So 292.65. So we know x is going to equal 293.15 divided by 292.65, then x is going to equal do the calculations, .002. So it's very close to this, similar to where it'd be at ground level, but just a little off. Okay, so the density actually went up a little bit to 1.002. That's all you have to do to figure out these calculations. Alright, I'll help you with one more. The rest will be on your own. So, to figure out temperature at 200 meters, alright, for 200 meters up into the atmosphere, our Celsius is 18.75, so that's pretty easy. Once again, we do 18.7. We add that to 273.15. That gives us, so 18.7, 273.15. Gives us 291.85. That's our absolute temperature at 200 meters. So 291.85. And then to find find that density at 200 meters, then we know we've got 1 times 293.15. That's our height and temperature at ground level. That's going to equal, and we're going to solve for the density at 200 meters, and then our absolute temperature we just solved for is 291.85 at 200 meters. So we know X, in this case, is 293.15 divided by 291.85. So X then, so 293.15 divided by 291.85, and it looks like we moved up slightly to 1.004 kilograms per meters cubed for our density. So 1.004. Alright, so this is how you're solving temperature, absolute temperature at each increasing height, and then how you solve for the density of that temperature in relation to those heights.